we need to use energy storage system, which is a battery in this case, to store the surplus energy from the generator, which needs to be stored in the battery for later use. And then we use an inverter to convert DC electricity to AC to make it compatible with the grid. And then control system which manages energy flow based on the demand, price, and the battery condition. And then we need to also release or store energy in batteries to the grid when based on the supply and demand. And we need to use a connector, circuit breaker, for example, for grid stability. And also monitoring and management system has to be there to make sure efficient operation of the whole energy storage system. So in the BES, the DC coupled BES, we use the batteries on the PV side of the system, where battery is connected to the PV array side of the solar inverter. And the PV array with charge controller and battery use the same inverter and share with the grid. And the high voltage battery is used to match PV voltage and to store the energy. And here is the drawback is that we cannot use the cheap rate electricity from the grid to charge the battery. And of course, usually no operation in the event of power failure. So there is an alternative. In the AC coupled BES system, battery is connected on the AC side of the solar inverter. Additional inverter or charger is required to convert battery power to 230 volt AC. And it is possible to charge the battery from cheap rate grid electricity. And also backup is possible with the additional switchgear, but the current needs to be converted a few times before using that. So in this BES setup, here it allows the operation in the event of power cut, and extra protection relays are required to enable AC loads to run either from the grid or to the battery. So this can be included in inverter or charger. This system has ability to support critical loads during power outages, and particularly for remote areas. That was all about the energy storage for grid applications, and thank you for listening.